Alrighty, the sliding ladder problem, the classic ladder problem. So here's my wall, here's my ground, and guess what? It's a ladder. Let's draw some rungs on our ladder to make it look very ladder-like. And I noticed that it makes a right triangle. So I'm going to label the sides of this right triangle A, B, and C. Since it says the ladder is 25 feet long, I know that the length of C is going to be 25 feet. If the foot of the ladder is being pulled away from the bottom of the ladder at a rate, so we're talking about the bottom of the ladder moving out at a rate of 14 feet per second. Well, since I labeled that side B, and I'm talking about the rate of that side moving, I'll use that 14 feet per second, and I'll call that dB dt. So the rate at which my B side is moving, we'll call it dB dt, 14 feet per second. Alrighty, at what rate is the top of the ladder moving down? So now we're talking about another rate. This time it's the top of the ladder moving down. So I'm going to call that rate dA dt. And I don't know what that is. That's what I'm looking for. When the moving down the wall, when it is 7 feet above the ground. So 7 feet above the ground would be my vertical part. So, you know, like on the wall kind of thing. So that'd be the A. A equals 7. So I've got a lot of information. There's still more information that I can find out. Because this is a right triangle, and I know that one side is 7 and the hypotenuse is 25, I can find that missing third side by doing Pythagorean theorem. And I know that the C part is 25. I know the A part is 7, and I can find the B part. All right, so we got B squared there, and let's run through the Pythagorean theorem real quick. So it looks like that, and then we subtract. B squared equals, all right, and then the square root of 576 should be 24. Cool. So there's the three sides of my triangle. I have all the information I need. Now I can find dA dt. So the way this works is I'm going to come up with a formula that relates all three of these sides together, and I've already done that. It's Pythagorean theorem, right? All right, after I have my formula, I'm going to run through the calculus because this thing is moving. And the derivative of a squared is totally 2a dA dt. The derivative of b squared is totally 2b dB dt. And the derivative of c squared is 2c. Whoa, dude. dC dt. All right, I know that I could divide out all those 2's and get rid of those suckers. And I would have what I have right there. Now I can go ahead and do my algebra. So the next step after you do the derivative is to run through your algebra, your substitution. A was 7. dA dt is what I'm trying to find. B was 24. dB dt is 14. C is 25. Oh, I never talked about dC dt. Holy cow, the rate at which our hypotenuse is changing. Well, unless this is a magic ladder or one of those like telescoping ladders, our ladder is not changing size, so dC dt would be 0. There we go. Now everything's plugged in, and I can totally solve for dA dt. Alrighty, so I got 7 dA dt plus 24 times 14. Smart man told me that that was 336. Ethan Martin. Now I can solve it up. 7 dA dt equals negative 336. Divide, and dA dt should equal a negative 48. So let's think about what that means in the context of our situation. dA dt represent the rate of change at which the ladder is going down the wall. So the fact that it's negative tells me, hey, it's going down the wall. So I could say dA dt equals negative 48, or in words, I could say the ladder is sliding down the wall. at a rate of 48, and A was measured in feet, and T was measured in seconds, so 48 feet per second. So notice I didn't include a negative in this answer because I already said that it was going down. So there's two ways to write our answer. In the context of the situation, as long as I say it's going down at a rate of 48 feet per second, I'm good. Or I can say dA dt equals a negative 48 feet per second, which tells me it's going down. The end.